Welcome to Chemistry World. In previous video, we have seen some simple problems in Werner's theory. Previous examples only that also. So in simple way, in the easy steps, how we have to solve that one we have seen. Little bit some length, some toughness that we increase. So in that, the first problem is in Werner's theory only. I am explaining the problems from Werner's theory only. Werner's theory. So I'm explaining the problems from Werner's theory. Now let's go for one more problem. Werner's theory, one more problem. Please excuse me for my writing. If anybody not understanding, ask me. Once again, I will explain. So let's go for another problem that was previously asked. What is the question means? I'm taking previous problems only. The primary and secondary valency of complex CONS3 5 times Cl and Cl2 as given is asking primary valency and secondary valency of the complex. Is asking what is primary valency and secondary valency. So let me see how to solve that primary valency and secondary valency. First thing, very be careful. So first you have to know the concept. Once again I'm saying, so first in this complex, what is primary valency means? Oxidation state of central atom. Primary valency nothing but oxidation state of central atom. After knowing the oxidation state, then we can easily write primary valency as well as secondary valency. So the secondary valency is nothing but coordination number. Coordination number of central metal atom. First one is oxidation state. Second one is primary valence means oxidation state. Secondary valence means coordination number. Coordination number is fixed and coordination number is non-ionizable. That is secondary valence is non-ionizable. Primary valence is ionizable. In this complex, what is oxidation state? Means what is primary valence? To calculate oxidation state, there is a formula. First, cobalt oxidation state we have to calculate. Here the central atom is cobalt. Central atom is cobalt. Let me calculate the oxidation state. Oxidation state of cobalt. So first we have to consider that as X because first one is there. After that there are 5 ammonia. Ammonia is neutral ligand. This is neutral ligands. Neutral ligand. For neutral ligands, charge is 0. So I am taking as 0 plus Cl minus is negative ligand. It is negative ligand means it has 1 unit negative charge. That is 1 chlorine is there. So minus 1. After that plus 2 chlorides is there outside. That is 2 into minus 1. Total charge of this complex is 0. I am taking like this. This is the way to calculate oxidation state. So first, let me write X plus 0 minus 1 minus 2 equal to 0. That is X minus 3 equal to 0. X equal to plus 3. This is oxidation state as well as this is primary valency of this complex. Plus 3. 3 is the primary valency of this complex. Let's come to coordination number, secondary valency. Secondary valency. Secondary valency means number of dative bonds. Number of dative bonds. Number of dative bonds. Number of dative bonds means number of coordinate covalent bonds. One ammonia can form 1 bond. So there are 5 ammonias. They are forming 5 dative bonds, and 1 chlorine is also there. That is also forming 5 bonds. So here that dative bonds are 6 is there. So this is the secondary valency of this complex. The primary valency is 3, secondary valency is 6. Like that you have to see. Primary valency is 3, secondary valency is 6. So answer is correct answer. This is one question. How to identify? Once again, I'm saying this is not the example. You can take any example. The procedure only like this. Primary valency means determination of oxidation state of central atom. Secondary valency means how many ligands are present inside the coordination sphere, coordination entity, we can say. And these different types of ligands are there. That's why you can say it as heteroleptic complex. Complexes are two types: homoleptic complexes, heteroleptic complexes. If only one type of ligands present in the complex, that is called homoleptic complex. If different types of ligands are present in the complex, heteroleptic complex. So here the coordination number is 6. So secondary valency is 6, primary valency is 3. Now let's go for one more question. According to Werner's theory, let's go over one more problem. I'm removing this one. This is the primary valency as well as secondary valency determination. And one more problem. Let me go for little bit depth or little bit tough sums. So if anybody has the doubt in this, you can ask me as the comment and all these things. And once again I'm saying, please be careful while solving the problem. So most of the students will not concentrate on the main point and they will try to solve the problems without knowing the main point. So don't do that mistakes. Let's go for one more problem. That problem is, one more problem is, on treatment of 100 ml of 0.1 m solution of COCl3.6H2O with the excess amount of AgNO3, 1.2 into 10 power of 22 ions are precipitated. This is the question he has given, and the formula of complex he has asked. Formula of complex. So this is one question, previous asked question only, that is important question. This type of model will become, let me see, solution. Once again I am explaining the question. On treatment with the 100 ml of 100 ml it is given 100 ml of 0.1 m solution of COCl6H2O with the excess of AgNO3 giving 1.2 into 10 power of 22 ions are precipitated. So the formula of complex. From these ions, first we have to calculate moles. If number is there, from the number we have to calculate moles by dividing that one with the Avogadro number. Why? Because 1 mole of any compound, number of atoms or molecules or whatever may be, it is made by constructive ions, that is things, you can say, you have to divide that with the Avogadro number. If I divide, I am solving the solution here, please check that one. Solution 1.2 into 10 power of 22 is there. If I divide that one with the 6 into 10 power of 23, approximately I am taking, because this is Avogadro number, 6 point, Avogadro number is N0, 6.023 into 10 power of 23, 22 into 10 power of 23 is the value, it is constant. I am taking here 022 as 6.022 as 6. So why? Because he has given approximately I am taking. So here if I write this one as 12 into 10 power of 21 by 6 into 10 power of 23 you can write. So 6 ones are 6 twos are 21. If it goes to up, it becomes minus 23. So 21, 23, if I remove 10 power of 2 will be there. So answer is 2 into 10 power of minus 2 moles are precipitated. From the number I have calculated moles. 2 into 10 power of minus 2 moles are precipitated. And from this complex, let me calculate the moles. From this complex, we have to calculate it moles. We have to calculate it moles. We need to calculate, because here I got 2 into 10 power minus 2 moles of precipitate. I got how many moles of this complex is there. To calculate moles, we have to divide ml, that is volume, into molarity. Moles is nothing but volume into molarity. That is 100 into 0.1 means it will be 10. It is ml is there, that's why it is millimoles we are getting. Millimoles. If I write that into moles, 10 into 10 power of minus 3 moles you can write. Why? Because 1 millimole equal to 10 power of minus 3 moles. So if I convert this millimoles into moles, it will be 10 into 10 power of minus 3. 10 into 10 power of minus 3 means what? 1 into 10 power of minus 2 moles we can write it is. 1 into 10 power of minus 2 moles. See, amount of precipitation moles is 2 into 10 power of minus 2, and amount of, that is moles of complex, is 1 into 10 power of minus 2. From this, what you can say means 1 into 10 power of minus 2 moles of complex giving 2 into 10 power of minus 2 moles of precipitate with the excess amount of Ag1O3, means 1 mole gives 2 moles. 1 mole gives 2 moles. Why? Because 1 into 10 power of giving 2 into 10 power of minus 2 means 1 mole gives 2 moles. 2 chloride ions are ionizable. 2 chloride ions are ionizable. Means these 2 chloride ions are present in a primary valency. These 2 are present in primary valency. Why? Because 2 chloride ions are ionizable. So 2 chlorides ionizable means the formula, if I write, there are 3 Cl3, 2 chlorides we have to write outside the coordination sphere, 1 chlorine we have to write inside the coordination sphere. Its coordination number is 6. CO3 plus coordination number is always 6. I already told it is fixed. So for that, if you write the formula, cobalt and H2O will be 5, 1 chlorine will be inside, then 2 chlorines will be outside, 1 H2O also outside, because 6 H2O is there, 5 plus 1 6 is there. This is hydrated molecules. These are coordinated molecules. These are linked to the complex by hydrogen bonds. These are linked in the complex by D2 bonds. So these 5 are coordinated, this one is hydrated. This is the formula of the complex. It was previous question. 2 moles, from 1 mole of the complex we are getting 2 moles of precipitate, means 2 chloride ions are ionizable. That means 2 chloride ions are present in primary valence. So if I write 2 chlorides in outside, 1 chloride should be in inside, and remaining 5 water molecules present inside, because its coordination number is 6. This is the formula from this question. Once again, briefly I am saying, on treatment of 100 ml of 0.1 m solution of COCl36H2O with the excess amount of AgNO3, 1.2 into 10 power of 22 ions are precipitated. So what is the formula of complex, he has asked. So first I have to convert these ions into moles. So I have divided these ions in with the Avogadro number. On division I got 2 moles of precipitate. Then I have to calculate moles from this complex, moles of this complex from this data. If I calculate moles, I got 1 into 10 power of minus 2 moles, means 1 into 10 power of minus 2 moles of complex giving 2 into 10 power of minus 2 moles of AgCl. 1 into 10 power of minus 2 moles of complex giving 2 into 10 power of moles of precipitate, means 1 mole of complex giving 2 moles of Cl minus ions. 2 moles of Cl minus ions are ionizable in the complex, means 2 Cl minus ions are present in the primary valency. 2 Cl minus ions present in the primary valency. Why? Because these are ionizable. So 2 chlorides ionizable means we have tried 2 chlorides outside and 1 chloride inside. After that we require 5 H2O because its coordination number is 6. So from this, all this data, the formula is this. Like this, you have to solve the problems from Werner's theory We have to solve the problems from Werner's theory like that. Please check that answer before removing that answer. If anybody doubt in that, please ask me. I'll go for next question. I'm going to next question. Let's take some tough questions. Let's take some tough questions on this. Yes, not that one. On Werner's theory only how to take. Just now I seen little bit tough some. Let me take Werner's theory. Werner's theory. Werner's theory. Not only this one, any question you can go for, like any question you can search any question like this and Werner series. Anything please, anything please. Let me get this. Yes, one more tough question he has given. Let's go for that question. I'm removing this. One more problem from Werner's theory. What is that problem means? First, let me write the problem. A solution of a solution contains, not of, a solution contains 2.675 grams of 675 grams of COCl3.6NS3, and he has given the molecular weight of this complex as 267.5 grams per mole. He has given is passed through cation exchanger. The chloride ions obtained in the solution were treated with the excess amount of AgNO3. Same model, excess amount of AgNO3. Then he has got 4.78 grams of AgCl. 4.78 grams of AgCl, and its molecular weight he has given as 143.5. 143.5 grams he has given. Then the formula of complex. What is the formula of complex he has given? Let's go for this problem. Formula of complex he has given. Please read the question before solving, before I am solving. How I am solving, before that please go through that question. You will get some basic idea. If you are not getting, no issue, I'll solve this one. Little bit tough. Little bit tough. Of course, Werner's theory lesson is easy topic, and whatever the sum coming from this Werner's theory is easy, no issues in that. But if the question little bit tough, it will be there like this. He has not given moles, he has not given ions number like that previous problems. He has given weight. So we know if weight we have, we can calculate moles by dividing with the molecular weight. Remember and say again, the quantity of the substance in chemistry is nothing but moles. He may give weight, he may give number, he may give volume or anything. First, convert the quantity of substance into moles. Why? Because the measurement of the quantity in chemistry must be moles. Don't compare the compounds, reactants, or products with other things. That is secondary issue. But first thing is you have to convert whatever the thing he has given into moles. So here he has given the weight of complex, the weight of AgCl. So we have to convert that into moles. First, I am converting solution. I am taking. I am converting complex. First, I am converting complex. 2.675 grams of weight he has given. If I divide that with the molecular weight, you will get moles. So weight by molecular weight is moles. So I am dividing. If I divide this one with the moles, I will get 2 points is there. So 10 power of minus 2 moles of complex I will get, because 2.67 by 267 means 1 by 100. 1 by 100 you can write it as 10 power of minus 2 moles. The complex moles here is 10 power of minus 2. And let me calculate this amount also into moles. So first, this is first one. Second one, I am taking precipitate. I am calculating the moles of precipitate. Here also same weight he has given as 4.78. 4.78. So if I divide that one with the molecular weight, you will get the molecular weight is 143.5 is there. 143.5 is there. We will get moles. How many moles if we get means, if we divide 143, 4.78 with the 143, 4.78 with 143, you will get the answer. Let me calculate that one. Is the calculator? Here it is. So if I divide 4.78 with the 143.5, I'll get 0.033. I'm getting 0.033. I'm getting. So these are the moles of precipitate. So 10 power of minus 2 moles. From this, what you can say means complex and precipitate, if you see, complex and precipitate, if you see, 1 into 10 power of minus 2 moles giving 3.3 into 10 power of, here also you can write as minus 2, 10 power of minus 2 moles of precipitate. So means 1 mole of precipitate will give 3.3 moles of precipitate. Means approximately if you round up that one, you will get 3 moles. Means 3 chloride ions are from one molecule, we are getting 3 moles of precipitate. So 3 chloride is, if I round up that one, 3 Cl minus ions are precipitated or ionizable. Ionizable means these 3 chlorides present in a primary valency. If these 3 present in primary valency, the formula of compound is CONH3. Same thing he has given, AgCl, A6NH3 has given us. So CONH36, inside nothing chloride, 3 chlorides are present outside itself. This is the formula. CONH3 6 times Cl3. So if you see that answer, yes, it is correct answer. Based on, once again I am saying briefly, a solution containing 2.675 grams of COCl, that is complex with molecular weight. When this is treated with excess amount of AgNO3, has got this much of precipitate and its molecular weight is 143.5. So I have converted this weight into moles. If I convert that weight into moles, I got 10 power of minus 2 moles. And if I convert this weight into moles, I got 0.33. Means 1 into 10 power of minus 2 moles of complex giving 3.3 into 10 power of minus 2 moles of precipitate in round of 3 moles. 1 mole giving 3 moles means 3 chloride ions are ionizable, means 3 chloride ions are present in primary valency. If I write the 3 chlorides on outside the coordination sphere, inside the coordination sphere 6NH3 will be there. The formula becomes CONH3 6 times Cl3. This is answer. Like that, you have to solve the problems in a Werner's theory. I have solved from simple problems to tough problems. More than tough will never be present from Werner's theory in any examination. Just convert weight, volume, whatever may be into moles. Then you will get the answer. Those amount of precipitate you are getting, that chlorides or that ions are ionizable, that are present in primary valency. So you can see ionizable valency. Like this you have to solve. Thank you.